Welcome to Section 4, Lesson 6. In the previous two lessons, we worked with the slope-intercept form y equals mx plus b, which makes the slope and y-intercept visible at a glance, and the point slope form y minus y1 equals m times the quantity x minus x1, which uses any anchor point as the reference. Today, we add the third canonical form for the equation of a line standard form, written as ax plus by equals c with integer coefficients a, b, and c. Standard form has a different set of strengths from the other two. It makes the x-intercept and y-intercept easy to extract directly, and it is the preferred form for systems of equations and for linear programming optimization work. Today, we lock in the standard form structure and the conversion procedure. First idea on the board. The standard form of a line is ax plus by equals c, where a, b, and c are integers and a is conventionally non-negative. The form treats x and y symmetrically on the left side, with no preference for either as a dependent or independent variable, and puts a single integer constant on the right side. Recognizing standard form on any equation immediately tells you that intercept-based graphing methods will work cleanly, and that the equation is set up well for combination with other equations in a system. Second idea, standard form makes both intercepts easy to find. To get the x-intercept, set y equal to 0 in the equation and solve for x equals c, so x equals c divided by a. To get the y-intercept, set x equal to 0 in the equation and solve for y equals c, so y equals c divided by b. Both intercepts are computed by a single division each, with no slope conversion required. The two intercepts are typically the simplest pair of points to plot when graphing a line, and standard form is therefore the most efficient form for the intercept-based graphing method. Third idea, standard form converts back and forth from slope-intercept and point-slope forms with simple algebra. Converting from slope-intercept y equals mx plus b to standard form requires rewriting m and b as integer fractions if they are not already, then clearing denominators and rearranging to put the variables on the left and the constant on the right. Converting from standard form ax plus by equals c back to slope-intercept just requires solving for y by subtracting ax from both sides and dividing by b. Both conversions take 5 to 10 seconds and are useful when a problem asks for one specific form or when one form is more useful than another for the next step of the work. The standard form of a line is ax plus by equals c with a, b, and c all integers and a conventionally non-negative. The form treats the two variables symmetrically on the left side of the equation with a single integer constant on the right. Every line, including vertical lines, can be expressed in standard form, while slope, intercept, and point-slope forms cannot represent vertical lines because the slope is undefined. Here is the intercept method workflow for graphing a line in standard form. To get the x-intercept, set y equal to 0 in the equation. The equation becomes ax equals c, and dividing by a gives x equals c over a. The x-intercept is the point c over a, 0 on the x-axis. To get the y-intercept, set x equal to 0 in the equation. The equation becomes bi equals c, and dividing by b gives y equals c over b. The y-intercept is the point 0, c over b on the y-axis. Step 1 in graphing. Set y equal to 0 in the standard form equation and solve for x to get the x-intercept. Plot the resulting point on the x-axis. This is the place where the line crosses the x-axis, with both coordinates of the form c over a, 0. Step 2. Set x equal to 0 and solve for y to get the y-intercept. Plot the resulting point on the y-axis. This is the place where the line crosses the y-axis, with coordinates 0, c over b. Step 3. Draw a straight line through the two intercept points and extend in both directions across the visible portion of the coordinate plane. The result is the graph of the line. The intercept method is by far the fastest graphing method for any line in standard form because both intercept points are computed by a single division each and the graph is determined by any 2 points on the line. Verify by substituting either intercept back into the original equation or by computing the slope between the two intercepts as a sanity check on the result. Here is the first worked example. Graph the line 2x plus 3y equals 12 using the intercept method. The equation is already in standard form with a equals 2, b equals 3, and c equals 12, so the intercepts are quick to compute and the graphing follows the procedure directly. Find the x-intercept by setting y equal to 0 in the equation. 2x plus 3 times 0 equals 12 simplifies to 2x equals 12. Divide both sides by 2 to get x equals 6. The x-intercept is the point 6, 0 on the x-axis. Step 2. Find the y-intercept by setting x equal to 0 in the equation. 2 times 0 plus 3y equals 12 simplifies to 3y equals 12. Divide both sides by 3 to get y equals 4. The y-intercept is the point 0, 4 on the y-axis. Step 3. Plot both intercepts on the coordinate plane. Mark 6, 0 on the x-axis and 0, 4 on the y-axis. The two intercepts together completely determine the line, since two distinct points always determine a unique line in the coordinate plane. Step 4. Draw a straight line through the two intercept points and extend in both directions. The line tilts downward to the right because as x decreases from 6 to 0, y increases from 0 to 4, indicating a negative slope. The line covers the upper right region of the first quadrant and extends into the second and fourth quadrants beyond the intercepts. Step 5. Verify by computing the slope between the two intercepts as a sanity check. Slope equals rise over run equals 4 minus 0 over 0 minus 6 equals 4 over negative 6 equals negative 2/3. The slope of negative 2/3 is consistent with the visual sense of a gentle downward tilt, and it matches the slope you would get by converting the equation to slope-intercept form y equals negative 2/3 x plus 4. Verification passed. So the line 2x plus 3y equals 12 has x-intercept 6, 0 and y-intercept 0, 4 and slope negative 2/3. The big lesson from this example is the intercept method graphing procedure. Set y to 0 for the x-intercept, set x to 0 for the y-intercept, plot both points, draw the line. The procedure is the fastest path from a standard form equation to a graphed line, much faster than converting to slope-intercept first and then graphing from there. Standard form is the natural form for intercept-based graphing, and recognizing the form immediately steers you toward the right method. Here is the second worked example. Convert the slope-intercept equation y equals 2x minus 5 into standard form ax plus by equals c. The conversion involves rearranging the equation to put both variables on the left and the constant on the right with integer coefficients. Step 1. Subtract 2x from both sides to move the x term to the left side. The left side becomes y minus 2x and the right side becomes negative 5. The equation is now y minus 2x equals negative 5, but the standard form convention puts x first, so rearrange to negative 2x plus y equals negative 5. Step 2. Make the leading coefficient on x non-negative by multiplying both sides by negative 1. The equation becomes 2x minus y equals 5, with a equals 2, b equals negative 1, and c equals 5. The convention that a is non-negative is satisfied. Step 3. Verify by reading off the parameters. A equals 2, b equals negative 1, c equals 5. All three are integers as required by standard form. The equation 2x minus y equals 5 is the standard form of the original line y equals 2x minus 5. Step 4. Verify the conversion by checking a specific point on the line. The original slope-intercept form has slope 2 and y-intercept negative 5, so the point 0, negative 5 lies on the line. Plug into the standard form 2 times 0 minus negative 5 equals 0 plus 5 equals 5. Match, so the standard form is correct. Step 5. Final answer in standard form 2x minus y equals 5. The big lesson from this example is the conversion procedure from slope-intercept to standard form. Move the x term to the left, ensure the leading coefficient on x is non-negative, and confirm that a, b, and c are all integers. The conversion takes about 10 seconds once practiced and is useful when a problem asks for standard form specifically or when the equation needs to be combined with another equation in a linear system. The reverse direction, converting standard form to slope-intercept, just requires solving for y as a function of x using the inverse operation procedure from section 3. 3 mistakes that catch every algebra student during their first weeks of standard form work. Each one is fixable with a small explicit habit applied on every problem. First mistake: leaving non-integer coefficients in the standard form when the convention requires integers. A student writes the standard form as 0.5x plus 0.25y equals 1 with decimal coefficients when the convention says a, b, and c should all be integers. The fix is to multiply both sides of the equation by a common factor that clears the decimals, often the least common multiple of the denominators. In this case, multiplying by 4 gives 2x plus y equals 4, a clean integer coefficient standard form. Always clear fractions and decimals at the end of the conversion to standard form. Second mistake: leaving the leading a coefficient negative when the convention says a should be non-negative. A student arrives at a standard form like negative 3x plus 2y equals 7 with a equal to negative 3 when the convention prefers a positive leading coefficient. The fix is to multiply both sides by negative 1 to flip all the signs 3x minus 2y equals negative 7. The two equations describe the same line, but the convention version has the non-negative leading coefficient. Apply this sign flipping step automatically as the last step of every conversion to standard form. Third mistake: swapping the intercept extraction rules and computing the wrong intercept. A student wanting to find the x-intercept sets x equal to 0 in the equation and solves for y, getting the y-intercept by mistake. The correct rule is to set the OTR variable to 0 to find the x-intercept, set y to 0 to find the y-intercept, set x to 0. The mnemonic is that the variable you want to find stays in the equation and the other variable gets zeroed out. Memorize the mnemonic and the intercept extraction becomes mechanical. Standard form is especially common in applied work that involves systems of equations or constraint optimization because the symmetric treatment of the two variables on the left side makes the algebra of combining equations cleaner. 4 broad sectors below. In linear systems of equations, 2 or more linear equations in 2 variables combine to find the unique intersection point if it exists. The elimination method, one of the standard solving techniques for linear systems, requires the equations to be in standard form so the variable coefficients line up neatly for cancellation. Section 6 of this course will cover linear systems in detail, and the standard form skill you build today is the prerequisite for all of that material. In linear programming, the foundational technique of operations research, every constraint in the optimization problem is written in standard form: ax plus by less than or equal to c, or ax plus by greater than or equal to c. The simplex method and other linear programming algorithms manipulate these standard form constraints to find the optimal solution. Logistics, supply chain management, scheduling, and many other professional fields rely on linear programming continuously, and the standard form notation underpins all of it. In mixture problems, often encountered in chemistry and pharmaceutical work, the constraints on concentrations and total volumes typically translate naturally into standard form. For example, the constraint that combining x liters of a 5% solution with y liters of a 15% solution produces a fixed total mass of solute translates to 0.05x plus 0.15y equals total mass. A standard form equation in x and y after clearing decimals. In economics, supply and demand curves are often modeled as linear equations in price and quantity, with the equilibrium price-quantity pair found at the intersection of the two lines. Both curves are typically expressed in standard form, and the equilibrium calculation reduces to solving a two-variable linear system. Microeconomic textbooks across the world use this standard form intersection picture as the foundational visualization of market behavior. 3 things to take with you from this lesson today. Standard form complements slope, intercept, and point. Slope forms with a focus on integer coefficients and intercept-based graphing, and it is the preferred form for systems of equations and constraint optimization work in applied math. First, the standard form of a line is ax plus by equals c, with a, b, and c all integers and a conventionally non-negative. The form treats x and y symmetrically on the left side and puts a single integer constant on the right. Every line, including vertical lines, can be expressed in standard form. Recognizing standard form on any equation tells you immediately that intercept-based methods will work cleanly and that the equation is set up well for combination with other equations. Second, to graph a line in standard form, find both intercepts and draw the line through them. Set y equal to 0 and solve for x to get the x-intercept. Set x equal to 0 and solve for y to get the y-intercept. Plot both points and draw the line through them. The intercept method is the fastest graphing technique for standard form equations and avoids any conversion to slope-intercept form. Third, standard form is the dominant equation form in linear systems, linear programming, mixture problems, and economic equilibrium analysis. The symmetric treatment of the two variables makes the algebra of combining and manipulating equations cleaner than other forms. Build fluency with all 3-line equation forms slope, intercept, point, slope, and standard so you can choose the most useful one for any given problem context. Coming up next, the lesson called Parallel and Perpendicular Lines, where the slope concept from the previous lessons combines with a small amount of geometry to identify when two lines never cross and when they cross at right angles. Parallel and perpendicular relationships are foundational tools for all of geometry and have many applications in computer graphics, architecture, and engineering.